Okay. We'll do some quick checks. No power on, things unplugged. The two IF cans transformers we're interested in. There's one here and one up here. Each one has 4 terminals. 2 primary, 2 secondary. Same with this one, 2 primary, 2 secondary. The primaries in these things carry B+, some at 100 volts or so. The secondaries are in the grid circuit. They're going to want to be somewhere towards ground. Same thing with this transformer here. The left-hand terminals here are going to be high voltage, 100 volts or so. The ones on the right feeding into the next stage, grid circuit, should be around 0 volts, thereabouts. I've already done this, but it doesn't hurt to double check, triple check. Are indeed all 4 coils, there's 2 coils in each transformer, of course, a primary, secondary. Are those all 4 coils, do they all have continuity? You know, so much wax and grime on here, it's a little tough. Okay, so this coil, let's call it 26 ohms. It's about right. Primary of this transformer. Let's look at the secondary. Yeah, about 23.5 ohms. So that looks right. It's not a dead short and it's not open. Is there any leakage between the primary and secondary? No. That's an auto-ranging meter and it's in megohm scale, so you know, just a little bit of leakage would show. So at least at whatever voltage this meter is putting out for the resistance measurements, which is below 9 volts, there's no measurable leakage. So to this meter, this coil looks just fine. Both coils in this transformer are not shorted dead, and there is continuity. Not what you'd want. Alright, so this can here. Okay, 16, call it 17 ohms on one coil. 15.6 ohms on the other coil in this transformer. So primary, secondary both check good as far as continuity. Now let's see if there's any current flow between the windings. There isn't. Not at this voltage, which is somewhere probably well below 9 volts. Not surprising. Trouble is with these, and there's a way to check for this. The capacitors in here, as I said, they're all a piece. They're all one sheet, and the conductive parts are separate upon this common sheet of, I think it's mica, I'm pretty sure. That's what makes sense. And contamination, humidity, various things can get in there. I think mostly it's humidity. And it causes a leakage path between the primary and the secondary. Primary on both of these is, both sides of it are the high voltage. See this red wire here? It goes right to this coil. And so this high voltage leaks across this sheet and gets into the grid circuit of the following stage. Well, when that happens, it biases that and it goes to crap. So what has to happen is that these coils need to come out, and that capacitor network in there, there's 2 capacitors which have a common dielectric, need to be completely removed and replaced with discrete components. Something that'll be the size of this, or probably even smaller. You could tack them, once you've taken this apart, you got to undo all these connections. Mark where they go, take pictures so you do not forget. Witness marks. Put a dot on the bottom of this and a dot on the chassis so you know exactly which way that thing went in before you pull it out. Trust me, you don't want to. That can cause you a lot of grief if you screw that up. So you can tack, once you remove the capacitors in there, you can tack values you suspect, and in these it should be about 130 picofarad to start there. Hopefully you've got a box full of various values close to that. You can try. You can just, once you get the can apart, remove the internal capacitors. I recommend, highly recommend, just put the can back in and tack your connections on, and put your capacitors out here at first. Don't put them inside the can. You should be able to, with a minimum amount of turning these slugs in these cans, get the thing to tune up. It helps a lot if you have some source of 455 kilohertz, at least for this particular radio, and most of them. Failing that, you can do it just by tuning in a station. What I'm probably going to do with this, I am certainly going to use the gear to peak it once I get these cans open. But I am going to just tack on these caps, one on each side, once I remove the internal one, and do an alignment on it and see functional test. Now if I turn the thing on and it's still wheezing and popping, I'm going to know, okay, that wasn't the problem, maybe it's this coil. My thinking is, if one's doing it, even if the other one is not, it's probably not going to be long before it begins doing it. So I'll probably end up doing both of these IF transformers, both of these cans. It's not that difficult in this particular chassis. It's not that difficult to get at things, nor is it difficult to document where things go. Just a couple of snapshots, this vent. That's what's going to happen. I am going to put some witness marks on before I do anything. Double check this electrolytic. I'm pretty sure he's okay. But one other thing I can do, I can actually measure some voltages. Now, as I pointed out, there should be high voltage on one coil of this transformer, and basically pretty much 0 volts on the other side, the secondary of this transformer, this IF can. Same thing with this one. I do have it safety checked. Okay, let's do something. Plug it into my Variac, set to read DC volts. I've chassised one side of my meter probe. This meter is isolated. This chassis is not isolated. If you're going to do this, you really should be using an isolation transformer. If you're going to be connecting it to frequency counters or signal generators, you have to. But for an isolated meter such as this battery, Fluke, you can get away with not worrying about that. But you do have to realize that this chassis could possibly have 120 volts on it, relative to your feet. So just be aware of that if you're doing this and not all that familiar. So, see, voltage down. I know the power switch on the radio is already on. Variac on. Crank up. Let's give it 80 volts or so. Yeah, see the heater's going in the tubes. Okay, I don't see anything. That should be, yeah, close to 0. Alright, let's do it the full Monty. Just for grins and giggles. What is... just realized this chassis is isolated. Very interesting. Okay, we can manage that. This black wire is ground and it goes right there to the oscillator. Now what do we have? Okay, that makes more sense. Alright, so the primary of this is 82 volts, 83 volts. The primary of this, 83 and a half. Okay, that's right now. It should be, that's bopping around quite a bit. I think that might be what's with this one. About 100 millivolts. That doesn't surprise me. This, we're at a volt, 1.2, jumping around the thing. On the other side of that same coil on the secondary of this, that's not definite. That's a trouble. Oh, it's all over the place. Okay. So I'm going to start with this coil. This chassis just kind of floats. That's unusual. The odds there's a capacitor connected to it somewhere for RF bypass. Actually, I think I saw one somewhere that was tied like that. Yeah. Anyway, don't worry about that right now. But this should be that should not be happening on the grid of the following stage. That's what's going on. This coil's, that 80 some volts is leaking from the primary into the secondary through that stupid common dielectric cap in that IF transformer. Okay, so I don't think I'll bore people with getting that out of there. It's not exciting. You just solder, you untwist the wires, and you undo the snap thing and come out. I might, like I probably will once I get that can out of there. As I'm opening it up, demonstrate what exactly is going wrong in there and why. I think I will do that. So, well, next time.